Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. Let's make a little bit of an announcement and officially start the stream as usual, Red Circle, live on Twitch. And what are we doing today on Twitch.television website? Today we are improving build configuration for Musializer. I'm gonna give the link where we're doing all of that, twitch.tv/Toding, and I'm gonna ping everyone who's interested in being pinged. So Musializer is music visualizer that we're developing for quite some time already, right? So you can find the source code in here. I'm going to copy paste it in the chat, and for people who are potentially watching all of that on YouTube, it is going to be in the description. So it's a pretty straightforward application, but today we're not going to talk about the application itself, but rather its build system. It has a pretty unique build system, and that build system is written entirely in C. In fact, to build Musializer, you don't need to have anything but a C compiler. Right, so, and that's kind of the point of the entire build system. So essentially, you may notice that there is no make files, CMake, or anything like that. The only thing there is knob.c. So, and that is the build system. The entirety of the build system is contained within the source code of the project, right? So imagine if CMake, the source code of CMake was part of the project. So to build your project, you first have to build CMake and then use CMake to build your project. You may say that it's kind of overkill, but this is because the source code of CMake is overcomplicated and overbloated. Right, so the source code of Knob is so simple, you can build it like this. You build the entire build system. That's it. The entire build system is already there. You have an executable, you can just run it, and if you run the executable, it builds the rest of your project. So, and what's interesting is that you don't have to rebuild it, right? So the build system itself serves as the script, as the actual instructions that that build your project. So if you make any changes in here, right? So knob log knob info hello, right? It will automatically rebuild itself, right? So it basically renames its own executable to knob old, then recompiles, and then runs the new executable, and the new executable actually prints hello that we put in here, right? So we can remove it and it will rebuild itself automatically, right? So the whole point is that you bootstrap the build system once with a very simple command, which is just cc-o knob.c, and that is it. You don't do anything else, and any special actions should be performed by the build system itself, right? So, and what's interesting is that there is a very common problem with CMake and auto tools and stuff like that, is that you may have a build system, you know, the script itself of the build system that is not compatible with the current version of CMake or AutoTools. It's not uncommon when you have to install a very specific version of CMake or very specific version of AutoTools just to build a very specific project. Since the entirety of the source code of the build system is contained within the project, you never have this problem. You actually never have this problem. So this is kind of cool. Right, so that's basically the unique build system of Musializer. And today I would like to address a very interesting problem that we have with this entire thing. The build system, the specific implementation in this project has a configuration. Right, and configuration has a few parameters. Right now it has 3, but I actually plan to have many of them. As the project grows, we're going to have more and more different parameters to customize for the project. So as right now, we have a target, right? So basically you can build for Linux, you can build for Windows, you can build for macOS. Hotreloading is a special feature for developers of the project, right? So basically an ability to make changes within the project and hot reload without restarting the project. It is very convenient. I use it all the time for developing UI. Right, it's kind of like, it's very difficult to develop UI without this feature. And here we have a feature flag. So we have unfinished feature, which I don't want to enable yet. So I put it behind the feature flag. So unless you enable it, the entire feature is disabled. And as we develop more and more different features, we're going to have more feature flags. So this entire thing is going to be more and more complicated. So the way it works, when you start Nope for the first time, we can actually try to maybe start it for the first time, but it's going to rebuild Raylib, right? So it may take a little bit of time, but maybe it's worth it actually. When you start it for the first time, it generates you a config file, right? So build config. Right, so, and if you look in here, you will find it in here. And you can actually manually change these parameters. There is also config subcommand that allows you to change these parameters via the flags and stuff like that. It doesn't really matter. Right, and then it just uses that specific configuration to perform the build. The inconvenience of this approach is that we have an extra code that generates the configuration, parses the configuration, serializes and deserializes the configuration, right? And all of that code is located within nope.c, right? All of that code is located within nope.c. So we have a special structure called config, and here are all of these parameters in here. Again, there's not that many parameters, but I do plan to have more of them. So this entire thing has to be, I'm gonna say that word. Get ready. Get ready. I'm gonna say that word. The whole thing has to be scalable. I just said that word. Anyway, so the whole thing has to be scalable. Right, you know what I mean. And yeah, so we have quite a few code to compute the default configuration, to parse the configuration from the arguments, right? So parse the configuration from the arguments, then log configuration, dump configuration. Like, look how much code we have just dedicated for handling configuration. Just for handling configuration. It's freaking insane. And if I want to add another parameter to my configuration, it's a major pain in the ass. It's a major pain in the ass. It's not scalable. Right. So we can try to do that, right? So let's actually add a parameter, like a Boolean parameter. Which is going to maybe enable like a nightly mode. I don't know what that means, right? But maybe it's some sort of like a nightly mode for using application at night. If you just add this parameter to this structure, nothing is going to happen. Like literally nothing is going to happen. It's not going to pick it up or anything like that. It's like useless. You have to perform additional things to actually, you know, make that work, right? So we have a special function that initializes the default config. Okay, so default config is mem set to 0, and that means that the nightly is going to be by default false. That is fine, so maybe we don't have to touch this specific function, we can just skip it. Parsing the configuration from the arguments. Now we have to think about like what kind of flag we're going to assign for the nightly mode, right? So we can say that it's going to be -n, right? If the flag is -n, what we have to do, we have to just enable the nightly mode, right? So, and you would think, okay, so that is enough. No, this is not enough, right? So this is only to handle the arguments of the config subcommand, right? Of the config subcommand. So now we're also logging the configuration when we are building. You probably noticed then when I build this entire thing, I also print the configuration, so I always know what exactly I'm building, with what configuration and stuff like that. This is very important. This is a very important UX. So you should not forget to add nightly in here, right? So, and nightly, as we know, is a Boolean, right? So it can be enabled or disabled. So that's basically what we're doing here. That is not enough as well. We need to be able to serialize the config when we're saving that configuration, right? So here is the dump config to file. So, and essentially what we have to do, we have to add a new nightly thing in here, like so. Luckily, you can easily copy paste all of that, right? So, but now we should be able to, I think, parse the configuration. Is that it? I think that's basically it. So Not really. Okay, loading the configuration, right? So essentially, when you encounter a new flag like nightly, you should essentially parse the boolean, right? You should essentially parse the boolean, and I think that is it. I think that's all of the actions you have to perform just to add a new Boolean field. But this is just a Boolean. Adding Boolean fields is easy because we have already developed code for it, like parse Boolean and stuff like that. If I want to add a flag of a different type, good fucking luck. You need to add support for that. You need to implement special parsing and stuff like that. Well, I mean, granted, over time it's going to become easier as you develop more and more different parses for different types, but you get the fucking point. I just want you to add a single parameter, and that's a major pain in the ass. I absolutely fucking hate it. And that's what I would like to address today. That's the topic for today's stream. I want to get rid of all of that bullshit. I want to get rid of all of that bullshit. It kind of reminds me of stats from Memcached. Do you guys remember the Memcached stream? Do you guys remember Memcached stream? So for those who don't remember, I think I'm going to leave the link to that stream in the description and stuff like that. So I think the stream was called like a best interview question or something like that. So let's actually see. Let's do best interview question. So we were hacking the Memcached, yeah, so the best coding interview question ever. We were hacking the source code of Memcached. And to add a new statistics to the Memcached, we had to modify, I believe, 6 or 7 different places. I think so. It's just like 6 or 7 different places. So it was freaking insane. And this feels like it. It feels like Memcached. And that is not somebody else's code. This is my code. I wrote this shit. I wrote this garbage. And I'm responsible for that. So I need to fucking fix that. I need to fucking fix that. So when I was actually writing that, I thought, like, I'm gonna just implement something to gather information, right? And I suppose I did. I understood that this approach is shit. So, I mean, to be fair, how else would I knew that this approach is shit if I didn't try it? So yeah, you fuck around and you find out. So that's exactly what happened. So I do not even regret implementing this entire thing, by the way. I do not regret implementing all of that because that actually gave me a lot of interesting insights. And in fact, I now understood how I can improve this entire thing and simplify it. I was thinking how I can approach this entire thing. And I think I finally found a pretty cool way to do that, which is also in a spirit of knob. Right, because this entire thing is too complex. It's not in a spirit of knob. It feels kind of alien. But I found a way to do that in a spirit of knob, and I think you're gonna like it because it's freaking cool. It's freaking cool, and it eliminates all of that bullshit from here. All of that bullshit immediately. Okay, guys. So, the most obvious approach that even chat suggested when I was developing this entire thing is to basically keep configuration in a C header file. And that is very appealing. That is very appealing solution. So let's actually try to explore that solution. I'm going to maybe create a separate folder, right? So maybe somewhere in prob, let's create knob config. Config, and this is where we're going to be exploring this entire stuff, right? This is where we're going to be exploring. So I think I want to just copy, you know, knob.h, right? So basically the library, the framework that we use for building and stuff like that. I'm going to copy it in here. So here it is. It's relatively big. It's not even that big. It's only 1,000 lines of code. 1,000 lines of code, by the way, is not that big. Just saying. 1,000 lines of code is nothing. Trust me, it's freaking nothing, especially in you know, Java Enterprise Edition development. It's literally nothing. Okay, so let's actually include knob.h. Alright, so we want to define knob implementation, because without this entire thing, knob.h acts like a header, meaning that it doesn't contain any implementations. So to indicate that you also want to include implementations, you have to define implementations. Right, so, and let's do the following thing. So maybe I'm gonna do usual thing with go rebuild yourself technology. Go rebuild yourself technology is extremely important. It allows you to automatically rebuild knob, right? So essentially now, if I just build this entire thing knob.c, right, and I just run it, it's not going to do anything. But then I can add knob log knob info hello, right? And if I run this entire thing, it will automatically rebuild itself and say hello. And that's basically what it is. That's what knob, like go rebuild yourself technology stands for. It allows you to automatically rebuild your C code, and that is very convenient. Okay, so basically, people were suggesting to have a configuration in a separate file. So let's actually create something like config.h, and you are supposed to modify that configuration, right? So basically, let's create like a config parameter called message, right? And we're gonna put hello world in here. And what you're supposed to do in your thingy, Majingi, you're supposed to do config.h. You're supposed to do config.h and just use that message, right? So we can just try to run this entire thing, and that seems to be working. That seems to be like a pretty good approach. That seems to be like a pretty good approach. Except I don't like this approach. I don't like this approach. Because config.h is something that is custom per machine of the developer. Each individual developer wants to have their own config.h with their own combination of parameters. And because of that, you don't want to commit that config.h. You don't want to commit that, right? Because of that, like, how can you basically work that around? How can you basically work that around? You can have something like in. So essentially, you can have a template file, and you can require people, right? So you can require people, okay, so you have to bootstrap your build system like so, knob.c, and you can't bootstrap it unless you have config.h. So now to just bootstrap your build system, you have to do a copy like this, and only then you can bootstrap your build system, and only then you can run it. That adds an additional step. That adds an additional step to bootstrapping the build system, and that is a huge no-no. That is a huge no-no. The whole philosophy of knob is based upon a premise that you can bootstrap the whole build system with just a single command and nothing else. You should not be doing anything else. If you want to do something else, additional actions, additional flags, or anything like that, you are doing it wrong. You are doing it wrong, and you might as well just use CMake at this point, because this is a very much a slippery slope. And it is a slippery slope because you add another additional step to bootstrapping, and another additional step, and another additional step, and then like you are building manually at this point. You're not automating anything. You know what I'm talking about? You are not automating anything at all. So some people suggesting to use environment variables. I think I can see somebody actually suggesting that. So using environment variables, you can do that. But one of the cool things about like a fixed configuration is that you don't have to provide the flags all the time. With environment variables, you have to provide environment variables in here, or you have to have them in the environment, right? You have to have them in the environment, and that means you need to have a separate file with the environment variables, and that is not particularly cross-platform, right? So on Linux, you are gonna have a file that uses bash syntax. On Windows, it's gonna be bat syntax. So this is completely not cross-platform. The point of this entire thing to be as cross-platform as possible, even though like you could use environment variables, but I think this is a too platform specific mechanism. I really don't like that. I really don't like that. So, but that's a good idea. That's a good idea. That's a good idea generally. So Yeah, so we can't just ask the user to do this copy manually, because that's against the whole philosophy. That's against a whole philosophy of knob. So what can we do? What can we do? I was actually thinking about it very, very hard for many days, maybe even weeks, because that had been bothering me for quite some time. It's just like, how can I make it so it fits the whole philosophy, ideology of knob, very convenient, and doesn't require like a shit ton of code for parsing, serializing, and deserializing. Like, how can I find this golden solution for this problem? And I think I found it. So you need to do an extra step. You need to do an extra copy. Why not just let knob do that? Why, like, I mean, so the problem here is that you can't build this program unless you have config.h. But what if you have two programs? I mean, you can chain this entire thing. So you have a high-level program that checks that config file exists and then generates that config file if it doesn't, then builds the other program that actually builds the rest of the thing and then runs it. So yeah. So essentially you have two knobs. The unconfigured one that doesn't know anything about config.h, doesn't include it, and the configured one which is linked with already generated config.h. So that is very interesting, actually. That's a very interesting idea. So let's actually start the following, right? We don't include config.h, we don't include anything. And here, let's assume that the job of this specific knob.c, is to check whether config.h exists, and if it doesn't exist, generate it. So that's the job of this specific knob.c, right? So we're splitting this job into two separate parts. How can we check if knob.c even exists, right? So essentially config.h. If I remember correctly, we have a function file exists, right? So it's a very simple function, right? So config.h. So it returns integer, right? And the reason why it returns integer is because it may fail. In case of a failure, it returns a negative number. So essentially in here, we just want to do return 1. And in case of an error, it also logs what exactly happened. So we don't really have to do anything. We just have to exit, right? So, and it's very convenient. If config does not exist, right? So it's equal to 0. We may want to go ahead and generate it. So the way I generate it is I basically usually collect some data into the string buffer, the string builder rather. So let's actually create string builder. And it's basically a stretch buffer for bytes for characters, right? So this is a content, like so, and we should be able to do sb append sister, right? We're going to be working with sisters. So this is a content, and let's literally generate C code. Let's literally generate a C code. So I'm going to do define message, right? Hello world, and a new line, right? And as we add more different parameters in here, we're going to have more lines that append to this content and stuff like that. Okay, so and the next thing we want to do, we want to dump this entire content into config.h file, right? So we have a special function for that. So write entire file, there we go. So this is what we will need. And so this is going to be config.h, and we're going to take the content. Can you see? Okay, so you can probably see what I'm doing. Content items and content count, right? And of course, this entire operation may fail. In that case, we should exit with non-zero exit code, like so. And there we go, right? So if the config doesn't exist, it is going to generate it. If it exists, it's not going to touch it whatsoever, right? So, and that is basically it, right? So that is basically it. Maybe we can even say something like knob log generating. So as I suppose it would be nice to maybe have something like config path, where we're going to hold all of these things. So this is going to be config path, like so, and we can now say generating config path, and this is going to be knob info. And if the config exists, we can say that this entire thing already exists. So there's nothing to generate in here. So that's basically the responsibility of this single program, right? Of this single program. We can rebootstrap it, then we can do the following thing. And as you can see, it generated config.h. We can take a look at that config.h. It does in fact looks like config.h. I can't complain. I can run it one more time, and it says that config.h already exists. It didn't regenerate it, so we can remove it, right? So this is not needed anymore. We can remove the generated config, run it one more time. It detects that there is no config, and it generated it for us. So then we can have knob2.c that already includes config.h. That already includes config.h. Right, and what it is going to do, it's going to do log knob info, and basically it is going to just use the message that you provided in here, and that is basically it. So the next thing we have to do in here, after we generated the config, we just have to build knob2. It's that freaking simple, isn't it? Right, it is that freaking simple. But here's the thing, like, we can be building this entire stuff on different platforms. So I can just go ahead and do knob cmd. So this is the command that is going to build knob cmd append, and I'm gonna say, okay, build knob2 electric boogaloo knob2.c and knob cmd run synchronous, right? So we're going to be running this entire thing synchronously, and of course it may fail, so if it failed, we're going to return 1. Okay, cool. And now we just have to run it. So we're going to do cmd count. It basically cleans up the list, right? So cmd is basically a list. You can clean up the list by setting count to 0, and so you can like append more things into it. So you can basically reuse the same command object, which is rather convenient. So, and I just do that, and I run it one more time, and that is basically it. So you're doing the build in two phases. And that actually kind of solves everything. Right, so let's actually try to run it. And something doesn't compile specifically in knob2. Okay, so what we essentially have to do in here, we have to include knob.h. Right, so yeah, that's the whole point. So the only thing the user of the build system has to do is just to bootstrap the little thing, and the little thing can have as many stages as possible. It's like loading up the operating system, right? In good old times, back in the days, we had MBR load section, right? Do you guys remember what it is? Like MBR load section. So it is literally 512 bytes, right? That just loads up a bigger loader that loads up a bigger loader, and then eventually loads up the whole operating system, right? So, and that's kind of a similar thing. You're just bootstrapping system with a single shell command that is simply cco knob.c, and then it by running this knob, it does everything to do as much for you as possible, right? So it may have several bootstrap stages, right? So it may just configure something and build up another program that also configures something and builds up another program, and then eventually like does a very complicated thing. You don't have to do any of that shit manually. The only thing you have to do is just bootstrap it, and the rest of the thing should be done for you. So that's kind of the philosophy of knob. I think it kind of demonstrates it really well what I'm going for, right? So this is what I'm going for. It's just like bootstrap it once and you have everything to do the rest for the user. Right, we have everything to do the rest for the user. All right, so let's enable the implementation, right? So, and see how it is going to work. So I'm running this thing, and as you can see, it is running the second stage. It's actually rebuilding the second stage always, regardless of whether it's modified or not. But the cool thing here is that it doesn't really matter, right? So, because it's so quick to rebuild the whole thing. Right, and now if I modify config.h and I replace this with foobar, right, I want to replace it with foobar, it is automatically replaced with foobar. So as you can see, we can have two-stage compilation. Right. But, so there's some problem in here. This is not cross-platform. So if you are building on Windows, for example, with MSVC, you have to use a different command. Or if you're using MinGW, you have to use a different command. So it is not particularly cross-platform. You know what is cross-platform? More or less, to some degree. Go rebuild yourself technology. So the cool thing about Go rebuild yourself technology is that it actually detects on what platforms and what compiler it was compiled with and uses the correct compiler correspondingly. So it does that by using a special macro called nob rebuild yourself, right? So, and this macro just checks the operating system and the compiler. If you're on Windows and MSVC, it uses this basically compilation target and stuff like that. So that's basically what is going on in here. And what I'm thinking is that we probably want to use that instead of whatever we have in here. Like, oh, actually in here. So what I'm thinking is that we can just go ahead and just replace this entire thing with this. Right, and the binary path is nob2, and the source is actually nob2.c, right, nob2.c, and that should be theoretically more cross-platform, right? So on Windows, it's gonna use the correct thing. It's kind of cool, right? So it says that config.h already exists, and if I modify something in here, it also rebuilds itself, right? So it just does everything correctly, and that's so cool, actually. That is so cool. And that is basically the solution that we can employ, right? So, and that doesn't require any special parsers or serializers because we're using the C compiler for parsing. Our parser is C compiler, right? And here is another cool thing, chat. The config is a valid C code. That means, theoretically, I may include that config in the main application as well. In main application may use the same source code as the build system, and that source code is generated by another stage of the build system. And now you finally understand why the stream is called Is this too much C Voodoo? So I'm passing that question to you, chat. Is this too much C Voodoo? But I mean, it kind of works, and it will allow us to get rid of all of that parsing generation code and actually eventually simplify this entire stuff. Right, so eventually simplify this entire stuff. So I think it's kind of worth it. It is C Voodoo, but it's not too much. It's precisely the right amount of voodoo, in my opinion, in my humble opinion. So somebody says that anything to do with building C is voodoo. Why? You want to see how easy it is to build C? Right. So look, single command. I just built C code. What the fuck? I thought it's so hard. I thought you need CMake to do that. Okay, just single command. Like, how is that even possible? Maybe all of the propaganda on programming humor was actually wrong, and you don't need all these overcomplicated tools to build C code. Goddamn Reddit propaganda. Anyway, so but here's the thing. This shit is ugly. This shit is fucking ugly. I mean, it works, it does exactly what we want, but it's fucking ugly. So can we just have a single executable? Can we just merge knob.c and knob2.c? Is that something we can do? Or is that gonna be too much voodoo? I think we can do that. So we can treat knob.c as unconfigured build and knob2.c as the configured build. And that makes sense. Like the first stage doesn't include config.h because it's unconfigured. We don't even know if config.h even exists or doesn't exist. We literally have no idea. And knob2 is the configured one. We, at this point, we already know that config.h exists. We're actually linking everything together, and it is the configured build. So there's an unconfigured build and configured build. We can actually merge this concept together into a single file, right? What if we literally had a special macro that tells the current program whether it is the configured one or unconfigured one? So if defined configured, what essentially we're doing this entire thing. Otherwise, if we are unconfigured, we're doing this program. So we're combining these two programs together, and depending whether you know, a flag configured or macro configured, enabled or not enabled, it's going to behave as configured or unconfigured build. So, and essentially, how we are building the second stage, right? Obviously, if you just do cco knob.c, you created an unconfigured build, because you didn't provide the configured flag, and you're not supposed to do that, by the way. You're not supposed to do that. To bootstrap the whole build system, this is what you're supposed to do, right? So if you have to do more, that's it. So you're going out of the ideology of knob, right? You go use CMake or whatever, right? So this is the only thing you have to do. So this is very, very important. So then, when we build in the second stage, we are using the same source code, but we can call this executable as something like maybe configured, right? So this thing is configured. Maybe config, maybe just, I don't know, configured, right? So let's call it configured, doesn't really matter. But you also provide this thing. Configured. There we go. So you also provide this thing, and then we're going to be just running the configured. So, and let's try to rebootstrap this entire thing. So something didn't work out. And goddamn JavaScript. I programmed in JavaScript for a couple of days, and it already damaged my brain. Holy shit. So it's a dangerous language. Don't program in JavaScript, kids. Don't program in JavaScript. So there we go. So let's see what is going to happen if we try to build this entire thing. Okay. All right. So that seems to be working. So maybe it would make sense to actually get rid of all of the generated stuff and start basically over. We don't need knob2 anymore, by the way. We actually merged everything together. Right, so initially we're starting with just that. Then we're bootstrapping knob.c, right? And there we go, we have an executable. We're running the knob, and what is going on? It generated config.h. Then it created the configured build, right, which includes config.h, and also we enabled configured. And we're building it from the same source code. And then we run this executable again, and that executable says hello world. We run it again, right, and it works as expected. So, and now we can go to config.h. We can replace it with foobar, right, and the entire build is going to say foobar. And what's interesting is that now we don't even have to commit config.h into the repo. We can just git ignore config.h, and each developer is going to have their own config.h that they can configure however they want, right? So, and yeah, so we have a single file and it works in 2 stages. And in fact, this several stages build is an extremely powerful idea. And I kind of want to explore it in the future, right? So what if, like, when do you need, for example, 3 stages build? But here is an interesting thing. This configuration step, in this specific configuration step, you have a Turing-complete language at your disposal, a system one that can perform syscalls and look at the file systems and stuff like that. So what if figuring out the default value for a certain parameter will require to check whether a particular executable is available in path? You can do that. You can actually do that, right? So that's how powerful it is. You can do extra steps in here to figure out the config and pre-populate the config for you. It's basically like, you know, the configure script from AutoTools. So, and speaking of using environment variables for this kind of stuff, can you do something like that with environment variables? With environment variables, can you have this perfect pre-configuration step that has Turing complete language, that has an access to the entire system and can do whatever the fuck you want? I think you don't. Well, you can kind of fit the environment variable idea on that, but it kind of overstretch. I think like if you're going to be having configuration step that generates a file with environment variables, you might as well just start doing this, whatever we did in here. So yeah. So I think that's a very interesting approach, and I would like to really explore that. So people comparing this kind of stuff with CMake, but here's an interesting thing. I already said that this thing has a huge advantage over CMake. It has a very huge advantage over CMake. So there is a very common problem that basically there is incompatibility between CMake list.txt version and your CMake executable version. So quite often, and that problem persists not only with CMake, it also persists with AutoTools. Quite often, to build a very specific project, you will need to install a very specific version of CMake. And that's a huge pain in the ass, right? So especially for me who's using Debian, right? So I always have to install a custom version of CMake for a latest project just to build a latest project on my Debian. Here, the entirety of the source code of the build system is located within the source code of the project. It never gets outdated. It never gets outdated. So you have the source code of the build system with you all the time. So, and if the build system is old, you're just gonna clone the old one and you just use the old one. It will just work. It will work for decades, for as long as the POSIX standard exists, right? So because it's using on the POSIX API and also Win API, for as long as POSIX and Win API exist. So, and that's a huge advantage over CMake. So I don't think it is comparable. It's good, but modifying C programs to build a project is meh. Sounds like a skill issue. Anyway, so I think we need to start integrating this entire stuff into maybe the main Musializer. Right, so I think we need to start integrating this entire stuff. But before we do that, before we start integrating this idea, and integrating this entire idea will require dismantling a lot of stuff within the Musializer, right? So I don't think it's going to be super trivial. Because the whole build system is like sort of built upon this configuration stuff, and it's going to be interesting to actually migrate all of that stuff. So yeah, but before we do that, I would like to make a small break. I would like to brew a cup of tea, right? So because I don't think I will be able to do that without any cup of tea. And yeah, so let's go. All right, so let's go ahead and try to migrate our Musializer build to the build that we just, came up with. I think it is going to be really, really interesting. So what kind of parameters do we have? I suppose we can just start with the configuration part, with just the configuration part. Okay, we can say that if we are configured, right? If we are configured, we're gonna just have our usual build in here, which is 698 lines of code. You didn't see that because Emacs is a dummy dum-dum, right? So this is basically the size of the build. And the reason why it's so big is because we also have like configuration, serialization, deserialization. I think overall this thing may become smaller after we employ our technique of two-stage building, right? So I think it may become smaller. Right, so and somewhere down there, we're gonna have unconfigured build. Why is it so weird? Okay, anyway. So we'll already include the knob and stuff like that, so that's totally fine. And maybe I'm gonna just go ahead and copy the config generator from here, right? So I think that's going to be very much useful. So the config path is config.h, and here's an interesting thing about this specific build system. We employ the build folder. We usually keep all of the artifacts in a build folder. So the unconfigured build might as well do the step of creating that build folder in the first place. I think that's an interesting idea. What do you guys think? I think that's an interesting idea. So this is how we do that, right? So essentially we do make dir if not exist, and we just create that specific folder, right? So we just create that specific folder, and we can keep build.h in there, right? So we can keep build.h in there, and that is rather convenient because config.h is an artifact that you don't want to commit because it's personal per developer. Each developer has their own config.h, and what we do in here, we actually git ignore build folder because it's one of the build artifacts. Right, and that is very convenient. We can keep all of the build artifacts in there. In fact, we can build the second compilation stage executable there as well, so to not pollute the root. Right, we already have you know, one executable at the root, which is the bootstrap, the first stage. Right, so we don't need to keep more in there. Right, so let's actually keep as many artifacts in the build folder as possible. Right, as many of these things in the build folder as possible. So we also have knob.old, which is basically the old executable when the knob tries to rebuild itself. Maybe at some point I'm gonna move knob.old to build artifacts as well. We'll see, because it's not particularly pretty in my opinion, right? It's not particularly pretty, but it's not that critical or important as of right now. Okay, so this is where we have config. Config exists or doesn't exist, and here we are essentially generating this entire thing. So what kind of parameters do we want to generate? So if you take a look at the config, we have targets, target, hotreloading, and microphone. Right, so and this is the thing that we can do in here. So how should I call it? Should I call it Musializer target? We can call it Musializer target. Right, and target very much depends on what operating system we're currently in and what compiler do we use. And this is rather interesting, right? So because if we are on Windows and if we're using MSVC compiler, building with MSVC is kind of a separate target. It is kind of a separate target. Might as well just take this entire sort of like a thing, you know, if else thingy, and just use it in the generation of the first parameter in here, because why not? Because why not? So the way we generate is essentially like this. Right, can you see shit? Okay. So this is the target MSVC, right? And we're gonna just use this entire thing directly. Right, so and in here, this is a target MinGW. Can you see that? There we go. So here, this is another target. This is a target macOS, right? So this is obviously a target macOS, and this is the target Linux. GNU plus Linux. GNU plus Linux. Okay, so when we do rebuild ourselves, oh, by the way, this thing is not particularly cross-platform, because on MSVC, you're supposed to do it with /d. Freaking Microsoft, like, okay, we can always have a special macro, something like define, right? So, which depending on the compiler just expands to a different thing, if you know what I'm talking about. Right? So, but I don't want to do it right now, so I'm going to put it to do, which says configured is not cross-platform. Right, so make a special case for MSVC, right? So I just don't really want to think about it too much right now. Right, so okay, and this is knob configured, and we can keep knob configured in the build folder. Right, we're building the same knob.c, right, but we're building this entire thing in there. So I might as well have something like configured binary, and I'm gonna just put this thing in here, configured binary. Binary. Gonna put it in here, and just like that, configured binary. There we go. So that should be the case. We're also running this entire thing right away. I think for now, I don't want to run it. I just don't want to run it. So I'm going to rebootstrap this entire thing, knob.c. Right, there we go. And that doesn't seem to be compiling because I forgot semicolon. There we go. So if I try to run this entire thing, what is going to happen? It generated config.h. Let's actually go into that file, and there we go. We have Musializer target, which is the target Linux, Isn't it poggers? I think it's pretty freaking poggers. So, and if you want to change that, you may change that directly in the config.h itself if you want to. Maybe we're going to add also some flags in there to influence what is picked, but I don't think it's that necessary. So the second parameter that we're going to have in here is going to be the hotreloading, right? So this one is rather interesting. I think it's pretty straightforward, right? So the hotreloading by default is disabled. Musializer hotreload, and it's going to be basically false. And another parameter that we have is basically microphone, right? Microphone is also disabled by default. To be fair, we don't really have to say that they're false. There could be just a macro that you if if you want to check for something. Yeah, so let's actually say they are like that. Okay, so let me get rid of config.h and rerun knob.h. So that should have generated new config. Let's take a look at it. And here is our freshly generated config. Right. Too much tea. All right. Tea spill. Minus deconfigured is cross-platform, just confirmed on my Windows machine with MSVC. I don't trust you, actually. cl.exe. All right, so minus deconfigured is cross-platform, just confirmed on my Windows machine with MSVC. So we can try to Google it up. MSVC define macro. So that is very unexpected from Microsoft. Like define macro flag CL, right? D preprocessor. So the only way I see it working is CL just allows you to replace slashes with dashes. Okay, so yeah, MSVC supports dash instead of the slash for options. Okay, so MSVC CL dash instead of slash. I want to see a confirmation from the source code. And we see MSVC compiler options. We might as well take a look at the Google, because I think Google is a little bit more reliable. Shows warning, compiler options. Okay, so the official documentation actually says that directly. Okay, all compiler options are case sensitive. You may use either a / or a dash to specify a compiler option. Okay, thank you so much. That's actually very cool. I didn't know that. I guess we learned something today. So that is not necessary apparently. So pretty much any compiler, you know, expects, like, I literally wouldn't expect something like that from Microsoft, because all Microsoft tries to do is to create as much inconvenience for everyone as possible. So basically you depend on this little thing and you can't get, like, easily get rid of it. Like backslashes for path separators, special new lines and stuff like that. So the list goes on and on. So I would expect Microsoft not to support this kind of thing, because it makes it too easy to migrate to a different compiler. It just, like, doesn't make sense from the Microsoft point of view. Something is really fishy in here. Understand the trust, glad to be shown right over. Yeah, I mean, I automatically do not believe anything people say in the chat, because chat has been bamboozled way too many times, right? So, but yeah, it's actually kind of good that it's actually true. So thank you for the heads up. Okay, guys. So everything seems to be working as expected. Right, and we may try to run the configured binary. So the thing about the configured version of the binary, we don't really need to rebuild it, in my opinion. We don't really need to rebuild it, I think. And another interesting part, so we have a system of subcommands. We have build, we have configure, which is not needed anymore, by the way. Configure is not needed anymore, so we might as well just straight up remove it. Right, so we have a dist, which builds the distro, right? So it builds the final distro that you can, like, basically upload to releases and stuff like that. We have SVG that compiles the, you know, SVG icons and stuff like that. That's very important command. Like, you don't want to run it all the time, but it's something just like handy to have. This is something handy to have. So, and I suppose when we're running the configured binary, one of the things we want to do, we want to pass the arguments that you provided in the first stage to the second stage, right? Because we still want to be able to have these subcommands, right? But now, if you provide the subcommand, you're providing the subcommand for the first stage. So the first stage has to pass those subcommands to the second stage, right? So that's kind of important. But here, this thing contains extra program, right? argv contains extra program. So we could, one of the things we could have done after we appended configured library, we could have done something like da append many, right? We can just, like, append argv argc. But that appends an extra program name. So one of the things we probably want to do is to maybe start with 1 and subtract 1 from here, or we may just basically pop out the program. So the usual thing that we quite often do. So program knob shift args, right? So we provide argc argv, and that pops out the program. And maybe we could use that program in the future for some reporting. Like, I don't see it being used right now, but we may, right? So, but that way it makes it easier to just append the rest of the arguments for the second stage and stuff like that. So then we can continue using the subcommand system, right? We can continue using the subcommand system. Okay, but the entirety of this thing still depends on old configuration style. It all still depends on the old configuration style. So I suppose one of the things we want to do, we probably want to basically start the compiler assisted refactoring. I'm going to straight up remove the config structure, right? And that is going to break all of the places that use that configuration structure, and we will be forced to go through all of the places and fix them. And eventually, by the end of that process, we're going to have a system that uses new way of configuring things, right? Namely the config.h thingy. And speaking of config.h thingy, we need to include it. We need to include it. By the way, we have a Raylib version 5. We might as well move that thing to the config file as well, because why not? Right. So, and adding new parameters to the configuration is now super easy. We can actually check how easy it is, because theoretically, instead of like 5 places, we have to now make modifications in 2 places maximum, I think. So let's actually go to prob knob config, right? So basically the playground, right? The sandbox. And let's imagine that we want to add a new parameter in here, right? So we're going to say, okay, now we have a parameter 1, literally parameter 1. And it can run this entire thing, and obviously it is not going to compile, right? So it is not going to compile because we don't have that param1. Okay, so we might as well just add that param1 to the existing configuration, param1, and yeah, there we go. So, and as you can see, it is working, and the second stage actually prints this entire thing. One of the cool things we can do, by the way, with this entire stuff, we can log the stages. We can log the stages. We can just do knob log, so knob info, something like stage 1. So this is the first stage, and then this is a stage 2, just to see where the stage 1 starts. That is actually a very cool way of denoting all that. Look at that shit. Right. So stage 1. And if you make modifications to the first stage, look how it's gonna go. Yeah, that's actually pretty cool. Right, so first it rebuilt itself, then it was stage 1, and then stage 2. That's so cool. I think I should keep that. I think this should be like a standard way of denoting. Okay, so this is a stage 1, stage 2. It's very convenient, very cool. And you can clearly see all that. Yes. And okay, but we made the modification in like 1 place, or actually 2, right? In the place we used the parameter and then we added the parameter to the config. But what about the default parameter? If I just remove the configuration and run it, as you can see, we generated the config.h. But the generated one doesn't contain the new parameter. So one of the things we have to do now, in the default config, we have to add the parameter in here. So it has to be param1. This becomes param1. So we need to remove config one more time, and we have to run it. And the new configuration actually contains everything we want to build. So adding a new parameter still requires modification in like 3 places, right? But I mean, effectively 2 places, right? So effectively 2 places. You just need to start using the parameter and you know, add it to the default configuration, right? All of the cases when something breaks are easy to catch. Generally, I think it's like generally easier to extend the config with this kind of system. I think it is. So yes. So here we have to include the config, and we know that the config is located within config.h. Maybe, by the way, we could have done config and just add build to the includes, but we don't really have to. So let's actually do it like that. So we're including config in here. So knob log. So I'm already back to Musializer, right? So I'm continue working on Musializer. So I want to add the stage 1. So this is a stage 1, right? And this is the stage 2. This is the stage 2. So what we did, we removed the config structure. So now if we try to run knob, it is not going to compile because look at all the code that depends on the configuration. So here is the first function that computes the default config. We don't need it anymore, right? So our config system is a completely different beast. So we removed a whole chunk of code, and this is what I'm going for, right? Hopefully by the end of this refactoring, we're gonna like dismantle the entire system that parses, configs, serializes, and stuff like that. We don't really need all of that stuff in here, right? We don't really need all of that stuff in here. So let's continue recompiling. So parse config, we don't need to parse anything. In fact, we don't need to log anything. I can remove all of these things right away, so they are not needed. Config. Oh my god. Parse target. Load config from file. We don't need all of that. Okay. So load available targets. Available targets maybe is useful for some stuff, but we'll see. We'll see. Okay. So what else do we have in here? Build Musializer. Okay. So when we are building Musializer, yeah, we have a switch case in here. But if we just remove the config from here, this one is going to be rather interesting, I think. This one is going to be rather interesting. So what I'm thinking actually is, so all of the build targets are located within a single function, right? They all are located within a single function. What if instead of a single function, we had several functions, like build Musializer per target, right? So essentially, if def Musializer target, actually not def, but if Musializer target equal to, so let's say target Linux, you're gonna have one thing, but it's not going to work, I think, because target Linux is enumeration, right? It is enumeration, and that means it would be better for this entire stuff to be macros, right? So yeah, we'll probably have to transform all of these things into macros, unfortunately. Right, we have to transform all of that into macros. I'm not sure if we need count targets. Do we need count targets? We do use targets for logging, but we don't really need to log that stuff anymore. So let's actually get rid of all of that stuff. So let's dismantle all of that, all of those things. Right, so for now, they are macros now, and they're specific numbers. So it makes it a little bit easier to do things like that. Okay, so, and in here, we're gonna have just a Boolean Musializer. So maybe I'm gonna copy this entire thing. So this is the usual stuff. And we also have a defer section that basically cleans up everything. So we wanna keep it in here. So speaking of Linux, right? So for Linux, this is how we build the entire thing. Right, so that's how we build Linux. And there is a separation specifically for Linux on hot reloading and not hot reloading, right? So we build hot reloading one way and without hot reloading the other way. And I remember seeing, yeah, so there was extra indentation and I accidentally ruined it. So let's not ruin it. So I'm gonna be a little bit careful, right? So there's a little extra indentation. So the code is rather complex, so, but I want to preserve the indentation because it kind of shows the intent. It kind of shows the intent. So this is just the Linux, right? So do we have else if or else if? I don't quite remember. So I think it's else if. C preprocessor else if, or is that elif? I don't quite remember. I think it's elif, right? For some reason I don't know why I forgot about that. Maybe I'm just like tired already. So the next target that we have in here is macOS, right? So this is macOS essentially. And we still need the same sort of preambular and postambula. Is that even a word? Do you even say like postambula? Maybe you do. Right, so this is the same stuff, and let's just copy the macOS thing. Ooh, and because all of that is macros, checking that on Linux might not work really well. Right, so some of the code, we can see if it's compilable or not when we actually use that on some of the platforms. So that's kind of a problem. But it's not that big of a problem, right? So I don't think it's that big of a problem. So this is the macOS target. All right, so the next one is going to be elif Musializer target. So what's the next one? So the next one is min64 min.gw, right? So this one is rather interesting. So let's copy paste this thing in here, and the post envelope, let's put it in here. All right. So, and boom, let's move it right here. Right here. So when are they going to invent an AI that is going to do all of that stuff for me? Right. So it would be kind of nice if I could tell the AI, just do it like that, and it will just do that for me. Is the code that I'm operating on even fits into their context window? I don't really know. Maybe it does, maybe it doesn't. So the last thing that we need to have in here is MSVC, right? So build for MSVC. And I suppose one of the things I'll have to do like after this stream is just like go into the Windows, right? And just checking if it still works on Windows. Yeah. And we're almost done, right? We're almost done. So you see, it's not really that scary to do very, like, you know, serious refactoring in just a text editor. It's not that hard, chat. It is not that hard. So in here, we're going to do and if Musializer, Musializer target. Right, so essentially, as you can see in here, we're like basically have one version of build Musializer for each individual platform. Right, depending on the platform, you just have like different versions in here. And so the versions themselves are not correct yet, because they, as you can see, they depend on config and hotreload. And hotreload is now a compilation, sort of like a flag. Right, so this is another thing that we'll have to refactor within those things. And the only thing we'll be able to check right now is only the Linux build. Right, so maybe also min.gw build. But I won't be able to check MSVC and macOS on this stream, right? So they're probably not going to be compilable, and we won't even notice that. We won't even notice that because like it's going to be stripped away from the actual source code. Maybe that's fine. Maybe that's fine. So anyway, we didn't even have to do elif, honestly, right? Because if one of the ifs is true, the rest of them are going to be false anyway, so... But maybe using elif is fine. I don't know. Okay, let's try to compile and see how miserably it is going to fail. There we go. It failed actually precisely as I expected it to fail, which is kind of funny, right? So it cannot find config hotreload, because now what you have to do is if def Musializer hotreload, right? If def Musializer hotreload, you do that, right? Otherwise, so this is basically else, you do that. And this is basically and if, and this is the Musializer hotreload, right? So, and that basically fixes everything, right? And we have an additional thing. Okay, here's an interesting thing. We used to check whether the microphone feature is enabled or not. So then we can pass the feature flag to the actual application, right? But look, now the feature flag is within the config.h, which is a C code that we can simply include in the main application as well. We don't have to pass it anymore. We can just include config.h in the main application as well. So the first stage of the build generates config.h, which is used by both second stage of the build and the application that is built. Think about that. I can even draw that. This is actually super cool. Just think about that. This is insane. Right? And all of that without any third-party dependencies like CMake or anything. This is just like a pure C. This is just like a pure, and it's all cross-platform. That's the cool thing. You don't have to install anything, or like it's so fucking cool. The fact that you can do that in pure C is fucking insane. I'm telling you. Right. So you have stage one. Stage one. So let me actually maybe switch to a different pen. Right. So this is stage one. one of the things the stage one generates two things, right? Stage one generates two things. It generates stage two and config.h. Right, so this is stage two and config.h. Config is used by the stage two, right? So it links with this thing. So one of the things stage two produces, it produces the app itself, right? It produces the app itself, like so, which also links with the config.h. So information about what features are enabled are also available to app without any extra work. It can just include config.h that is generated by the stage one. Isn't that cool? Like, again, I mean, like the build system been doing something like that for ages, but it's a pure C without any third-party dependencies. It's never gonna get outdated. It's all part of your code base, and it's cross-platform. It's just like, like the fact that you can achieve all of that in pure C is so cool. I think it's pretty cool. I think it is. C is great. No, this is not what I'm saying, by the way. I'm not saying that, oh, C is such a cool language, everyone should program in C because you can do that and that. No. This is not what I'm saying. C is shit. But even with such shitty language as C, look how much you can achieve. That's what's amazing. It's not C that is amazing. C is not amazing. Like, I wish we could fucking finally replace that language. But the fact that using this oversimplistic old language, like C is like half of a century old. It is half of a century old language. We should finally fucking retire it. But yet, look how much you still can achieve with it. That's what I'm saying. It's not about C. It's not about C. Okay? It's about simplicity. It's about simplicity. If you just keep these things simple. Right. So let me see what we can do in here. Can I just now do nop cmd append? What we can do? We can append maybe. Yeah, we can say use build as the search folder, right? Use build as the search folder, and we're gonna include. We're going to include config.h in the Musializer, right? And then we're going to use that to check certain things and stuff like that. Okay, so let's actually try to compile. Let's continue compiling the things. Okay, so what do we have in here? Config.target. And we use the names. So this is what we used names for. This is what we use names for, because when we build in ArrayLib, yeah, depending on the target, we just have like separate folders for different targets and stuff like that. Right, we just have separate targets. So maybe we should bring back the target names that I so foolishly removed. So let me do it like that. But it's not particularly convenient in my opinion. So let me revert the entire changes just to. Yeah, so here they are. Here are the targets. So since we moved the targets to macros instead of enumerations, pulling off something like that is not that easy anymore, in my opinion. It is not that easy anymore. So we'll have to think how to approach all of that. But for now, I suppose I'm gonna just keep it like this. Okay. All right, so I'll think about that. All right. So what else do we have in here? So this is the target. We might as well just use Musializer target, right? So this is a Musializer target. To be fair, when we specify the target, we could have like. Can we use like string literals? Can we do comparison on a level of string literals in the preprocessor? Is that something you can do? Can you do shit like hello equal world in a preprocessor. Does anybody know? I never done anything like that. I've never done anything like that. That's kind of interesting actually. So let me see. Full C. Right, so let's include stdio. Right. So if hello world, we're gonna say printf yes, else no, and if. So let's try to build foo.c and run this entire thing. So talking hello is not a valid preprocessor expression. So yeah, you can't do that. You can't do that, though you can use numbers. If I'm not mistaken, numbers are fine for this kind of stuff. And if you have a different number, right, that are not equal, so you can only compare numbers. You can't probably compare floats, right? So yeah, so floating constants in preprocessor expression. So you can only do integers. Can you do characters? Can you do characters? You can do characters. Look at that. That's very cool. So you can do integers, you can do characters. You can't do strings. So yeah. Okay. We'll have to remember that, but it's really not that important, to be fair. It's really not that important. Let's continue compiling and fixing the compilation errors. So what else do we have in here? Okay, so this is another thing. All right, so let's simply add build into the search path, right? And we don't have to do that anymore. Okay, so this is the target, Musializer target. There we go. So I suppose we just have to go through all of these things and do something like this. What else do we have? Actually, a lot of... One of the things we can do, we could maybe introduce like a Musializer target name, right? So essentially, if Musializer target equal target Linux, right? Target Linux. What we do, we define Musializer target name equal to Linux. And if you want to have a target name, you just use this macro and we can get rid of this thing. But I don't really want to do it right now. I don't think it's that important right now. So, right. So I'm going to just put it to do get rid of this array, replace it with macros, right? So replace it with macros. So let's try to recompile this entire thing. Okay, build raylib. Ooh, and this one, okay. Oof, this is... Right, so because we have different builds for different platforms and yeah, yada. Oof. Oof. Okay, so, and this is going to be very much similar, right? So this is going to be very much similar. And I wonder if we can maybe even, just put that under the same thing. You know what kind of idea does it give me? Right, because we have build Musializer, build raylib, and sort of for each platform, it is kind of different. What if we've put each individual platform specific functions into separate files? Right. So you have a file that contains everything for building for Linux. You have a file that contains everything for building for Windows, and so on and so forth. And those are separate files, and you don't have to think about if else is too much in there. Right. And so it depending on the current target, you would just include a different file. It's kind of interesting how like changing the approach to the configuration actually starts to affect the architecture, and it makes it actually easier to add new platforms. Actually, if you think about it, it makes it easier to add new platforms. That's so cool. That is actually super cool. All right. So maybe we should actually start doing that. But how are we going to be approaching this thing? And by the way, if we're including a different file, yeah, so essentially what we can do, how can I do that? Nob linux.c, right? So this is a nob linux.c, and I can just move this entire thing in here, right? I can just move this entire thing in here. So this is a build Musializer, and as you can see here, I'm doing this thing. I can go ahead and query replace this stuff with just Musializer target name, right? Musializer target name, and for this specific file, I can define Musializer target name to be Linux, right? Because it's dedicated to Linux, right? So I know what it is. I know what it is. All right. So that's kind of cool. So, and that kind of gets rid of this thing. We don't really need it anymore. And in here, instead of like including this file, we can just include nob linux.c. So yeah, right. And basically it implements the interface for the build, right? So it implements build Musializer. It also going to implement build Raylib for that specific platform, and so on and so forth. Okay, that is pretty cool. All right, so, and of course for macOS we're gonna have a separate thing. We might as well even just do nob macOS.c. We can even put all of these files into separate folder. Like, you know how for CMake there is a CMake modules folder for additional things. We can also put it there, right? So who said we can't do that? We can do that. Right, so this becomes macOS, and it will allow us to manage complexity a little bit easier. I think it will allow us to do that. So nob win64mingw.c, right? So we can move that stuff in here. It's not compilable, but it doesn't matter, right? So I'll fix all of the code after this stream. So what's important is like a general idea. Nob win64msvc c, and we're moving that stuff in here. And it's so nice to finally move all of that crap like somewhere else. Right? mingw, it's actually msvc, sorry, msvc. So we also have Raylib modules, and they're going to be common among all of these sort of like builds. So I think it would make sense to actually put this stuff in here. Okay, so build Raylib. What I'm thinking, I'm going to move this thing to the Linux version, right? So the Linux version is going to provide build Raylib, but on top of that, I don't want to remove this version because it contains parts of the code that are useful for other things in here. So for now, I'm gonna just comment it out, but I'm gonna comment it out with macros, like so. Right, so something like this. Okay, so let's try to build this entire thing, and let's see where it is failing. So it is failing in nob linux.c, right? As you can see, that's exactly what's going on. Yeah, we're referring to the target, to Musializer target name, but we already have this thing defined in here. So we might as well just start using that instead. Okay, so what else do we have in here? So depending on the target, yeah, there we go. Now here, we don't even have to, you know, think about the target too much, right? We don't have to think about the target too much because we know for sure that this is Linux. So yeah, separation, like it just simplifies everything. I really like how it simplifies everything. So freaking cool. Okay, and even in here, as you can see, we have separation. What's Linux, what's not. It doesn't matter. We know we're at Linux. Everything that is not Linux can be removed easily. It just like makes everything simpler. It simply makes everything simpler. Okay, so and for this entire stuff, it also not important. It is also not important. So MSVC, some other shit, does not matter. Does not matter. So do we have in here? It also is not needed. I hope I didn't remove too much in here. I think I didn't. Yeah, so this is the final build of the thing. And there's a little bit of a difference between like hot reloading and not hot reloading, right? So if we enabled hot reloading, we building DLL, right? This one is not Linux. It doesn't really matter. So it's, yeah, so we can remove that. Okay. We're removing code. We are removing code. So not hot reloading. So that means we need to replace this entire stuff with macros. If not defined Musializer hot reloading, we do that. Then this is else, and then the final thing in here. And if Musializer hot reload. Okay. So there's a little bit too much, yeah, a little bit too much indentation that I would like to get rid of, but maybe not. Yeah, no. So let's actually get rid of this indentation. It's redundant. Overall, code becomes simpler, and I really enjoy that. I really enjoy that. Okay, so the entire thing actually compiles in here. So now it complains about build dist. And again, build dist is also dependent on the current target. So that means it's going to be part of the interface. So I'm going to move it to the build Linux in here. And I'm going to also comment it out like so. All right, because we're going to use this code to populate the rest of the build things, right? So we're going to use that to populate the rest of the build things. And what do we have in here, right? So we don't have a config anymore. And this kind of stuff is only supported for like without hot reloading, right? So we don't ship with hot reloading and stuff like that. And by the way, one of the things we can do in here, if defined Musia, well, this one is, yeah. So I suppose we can do if defined Musializer hot reload. We're gonna replace the whole implementation with just that, right? Which errors out, which is fine, right? So you're building the final distro that you're supposed to upload and ship to the user. We do not ship to the user hot reloading, so that's why we want to error out in here. And we don't really need to check for the platform because we know we're on Linux, right? So we can just straight up remove all of that stuff in here. Right, it's greatly simplifies. Each individual platform is going to have their own like file. Okay, so that is cool. And this is else, so that means we want to put and if in here Musializer hot reload. So let's see if now it compiles, right? So okay, so that code compiles, and now we need to fix the build thingy. In the build thingy, by the way, in a build thingy where loading configuration and stuff like that, none of this stuff is needed anymore, right? So when we start building, we don't need any of that stuff, right? But we also like log the configuration, we print what is the current configuration. How can we easily do that? We can just print the contents of the config, right? We can just print the contents of the config, but maybe for now, I don't know, I'm gonna put it to do in here, right? So print the current config somehow, because it's useful information, right? Because when I'm building something, I want to have a context of like, what exactly are we building, right? So I think it's kind of important. So here we're building array-d, but we don't accept config anymore, so we don't need any of that stuff. So then we're checking for the configuration. This one is rather interesting. So I think this kind of stuff should be moved to MinGW. It should be part of building Musializer for MinGW and MSVC. Right, so I'm gonna put it to do in here. So move the copying of to knob win64. Let's actually denote them as star because there's two of them. Like, yeah, so move them to the corresponding builders, right? So there's no place for this thing in here. And then we're copying the resources and stuff like that. So this is the building the distribution, so we don't need to load the config anymore. And this is how we simplify this entire stuff. All right. If I try to build this entire thing and it works. That's it. That is basically it. Believe it or not, that is basically it. Right, but what's funny is that it actually built for hot reloading. But by default, I don't want to enable hot reloading, and this is because I'm a dummy dum-dum. Right, so it defined all of these things. So what I probably want to do, when I'm generating the default configuration, I want to actually put these things commented out, indicating that they kind of exist, but they disable by default, and if you want to enable them, you just uncomment this specific thing. So if I go ahead now and remove the config.h, right, like so, and then try to build this one more time. So what does it say? Right, so you see, we actually hit some code that was never compiled before, and it doesn't compile, as you can see. Yeah, it doesn't compile. So we're checking for microphone stuff. We don't have to do that anymore, right? So that was actually a good idea. So instead of forwarding this stuff to the microphone, we just add this thing to the build. What else do we have in here? So we need to replace this thing with Musializer target name, right? What else do we need? And that's it. Okay, so that's cool. That is very, very cool. So, and if you want to enable hot reloading, right? You go to here, you enable hot reloading, right? And there you go. You've got hot reloading. Do we pass? Yeah, we still pass hot reload macro in here. But let's actually take a look at where we check for this macro in src. So rn if def hot reload. Okay, so there's only one place we check for this macro. What if we actually checked for Musializer hot reload and included config.h? Precisely what I was talking about, right? The main application includes the same config as the second stage of the building. So, and in here, so if I go to Nob Linux and try to find hot reload, right? So there's one place we don't have to pass that thing anymore, right? Hopefully, right? So I'm gonna try to do the build. And it seems to be working. Does it enable hot reloading though? We can try to check it out. I'm going to set the Musializer, right? So, and we can already check it, right? So I can go ahead and go to plug.c and find drag and drop, and we can simply rename this entire thing to your mom, as usual, right? So I'm gonna go ahead and recompile this entire thing and hot reload, and there you go, your mom. So hot reloading is working. In fact. So we can try to rebuild that one more time. All right, so go and drag and drop here. So we can now try to disable hot reloading. What if I don't want hot reloading anymore? So it doesn't build a so folder, right? And now if I try to run this entire thing and go to the plug and just go ahead and replace all of that thing with your mom, right? So, and yeah, nothing happens. So that's pretty cool. there's no hot reloading. There's no hot reloading, which is precisely what I wanted. So we can also test for the microphone. Okay, so we test whether a microphone feature is enabled by looking at the feature microphone. Let's take a look at in how many places we check for that thing, right? I'm pretty sure. Okay, there's quite a few places. In MinJW in here, we're still checking for that. Okay, so I suppose I'm only interested in these things. Let's just go ahead and query replace. So you probably can't see this thing. Just a sec. Right, I want you to be able to feel, to see like everything. So feature microphone, Musializer microphone. Right, let's replace this stuff everywhere, so that we can use it everywhere. So we already include configuration in plug.h, right? Do we? I don't think. Where do we include the config? So is it hot reloading? Yeah, we include it in here. And hot reloading. Okay. So I suppose we will need to include config here as well. Okay. So let's go ahead and try to rebuild the entire thing and see if it works. Okay, I'm gonna do this thing and I'm gonna press C. C doesn't work, that means the microphone is not enabled. The microphone is not enabled. We go to the build, config.h, I enable microphone, I rebuild the whole thing. I run Musializer. See, microphone is working. So feature flags are working as intended. Holy shit, that is so cool. So that's pretty cool. So I can control all of that stuff. I can actually control all this stuff. So, okay. That is a very cool approach. That's a very cool approach. It's way better, right? So because it's so natural, and it's like, it's basically like with the same philosophy as Knob, right? So whatever I used before that felt kind of out of place, but now, right, so you just have a configuration and you do not compromise on anything. You do not compromise on anything. You don't introduce an additional step into bootstrapping. You still bootstrap with a single command, which is very simple. And yeah, that's perfect. That's perfect. So, and when you generate in the default config, you may also generate like additional comments maybe that explain you how to modify this entire thing and everything. So why not pass the config via CMD arguments? Imagine that you have 10 parameters. Imagine that you have 20, 100 parameters. So you're gonna pass 100 parameters? So you may say, oh, I can save that to the shell script. But wait a second, shell script is not cross-platform. And so that means you need to start having separate shell scripts for each individual platform, for Linux, for Windows, maybe for Mac OS, because it uses slightly different shell and stuff like that. But I can just run this thing from C instead of shell. And that's basically what it is. So yeah. And here's an interesting thing. You probably noticed, if you ever build Linux software with AutoTools, you notice that you have a separate step for configuring build and then building, right? You do configure, you provide shit ton of arguments to the configure script. It saves them all to a separate file, configures everything, figures out the rest of the stuff, and you never provide them ever again. And make that you do make and make install and so on and so forth, it just uses whatever the config script generated, because the amount of parameters may be so big that it's not worth providing them all the time. You just want to configure it once and just rebuild it constantly. All right, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. I love you all. Mwah.